Welcome to the today's topics, problems on Cauchy Euler Differential Equation. I am Dr. N. Cauchy, Associate Professor, Department of Mathematics, Kamaraj College of Engineering and Technology. In the previous video, we have seen the basics of Cauchy Euler Differential Equation. Here we solve one more problem in this type. So before going to solve the problem, let us see some quick review on complementary function, how to find complementary function when their roots are known. Suppose the roots of the auxiliary equation is 2 and 3, the complementary function is a into e power 2x plus b into e power 3x. If the roots are complex, that is say for example minus 1 plus or minus 2y, then the complementary function is e power minus x into a cos 2x plus b sin 2x. If the roots are all are 3 3 3, so we have the complementary function as ax square plus bx plus c into e power 3x. If the roots are 2 2 1, then the complementary function is ax plus b into e power 2x plus some constant c3 into e power x. So now let us solve this problem. X square d square minus xt plus 4 into y is equal to cos of log x plus x into sin of log x. So here we have x square d square minus xd plus 4 into y is equal to cos of log x plus x into sin of log x. So first we have to change the given differential equation into constant coefficient. How we are going to change? By making the substitution x is equal to e power z, that is z equal to, you take both sides log, you will get z equal to log x, then xd becomes theta, x square d square becomes theta into theta minus 1, theta into theta minus 1. So we know here d is d by dx and theta means d by dz, the variable z, right? Now we make this given differential equation into constant differential equation by making the substitution. So theta into theta minus 1 xd means theta plus 4 into y, which is equal to cos of log x is log x is z, therefore cos z, x is e power z, so sin of log z is log x is z, sin z. Now if you simplify this, theta square minus theta plus 4 into y is equal to cos z plus e power z sin z. Now this becomes theta square minus 2 theta plus 4 into y is equal to cos z plus e power z, cos z plus e power z into sin z. Now you see this last equation is a differential equation with the constant coefficient. How we are going to solve this? First we have to solve the equation by finding auxiliary equation. The auxiliary equation is, so finally we arrived theta square minus 2 theta plus 4 into y is equal to cos z plus e power z sin z. So the auxiliary equation is m square minus 2m plus 4 is equal to 0. So, how we are going to solve? So, we cannot factorize directly. So, we use the formula m is equal to minus b plus or minus root of b square minus 4ac by 2a. So, here you know what is a is 1, b is equal to minus 2, c equal to 4. So, minus b, so already b is minus 2, therefore it is 2. So, plus or minus root of b square. So, minus 2 square is 4, minus 4 into a is 1, c is 4. So, what do you get? 2 into a is 1. So, 2 plus or minus 4 minus 16 by 2, which is equal to 2 plus or minus root of minus 12 by 2, which can be written as 2 plus or minus I into 2 root 3 by 2. So, which is equal to 1 plus or minus I into root 3. Since the roots are complex, the complementary function CF is e power x, here the variable is z, so e power z a cos root 3 into z plus b sin root 3 into z. But z is all of you know z equal to log x. So, if you make a substitution, it will become e power log x a cos root 3 into log x plus b sin root 3 into log x. So, here e power log x is x. So, x into a cos root 3 into log x plus b into sin of root 3 into log x. So, this is our complementary function. Okay. Next, let us find the particular integrals. Here there are two terms in the right hand side, namely cos z and e power z sin z. So, we find particular integral one by one. So, first we consider the function cos z. So, pi1 cos z by here theta square minus 2 theta plus 4. Here rule is when sin cosine comes, the rule is you have to replace theta square by minus 1 here, the coefficient of z. So, cos z by minus 1 minus 2 theta plus 4. So, this will become cos z by 3 minus 2 theta, which can be written as, actually we have to multiply the conjugate of 3 minus 2 theta, namely 3 plus 2 theta in the numerator and denominator. We will get 3 minus 2 theta, which is equal to 3 plus 2 theta into cos z by a plus b into a minus b. So, 9 minus 4 theta square. So, once again you have to replace theta square by minus 1, you will get 3 into cos z plus 2 into theta into cos z. Theta into cos z, we have to differentiate cos z with respect to z. So, we will get minus sin z. So, what do we get? Here minus 2 into sin z. So, here 9 minus 4 into theta square is minus 1. So, I will get 3 cos z minus 2 sin z by 9 plus 4, that is 13. So, finally, what do we have? 3 cos z minus 2 sin z by 13. So, this is our pi1. Finally, we have to replace this z by log x, that is pi1 finally Pi1 is 3 cos of log x minus 2 sin of log x by 13. Okay. Next we are going to find the particular integral of the second term, that is e power z. We will see. So second term is e power z sin z. For that we can find so Pi2 e power z sin z by theta square minus 2 theta plus 4. Here rule is we have to replace theta by theta plus 1, because here e power z and some other function comes. So this is of the form e power ax into some function of x. So we have to replace theta by theta plus 1. What do we have? E power z into 1 by theta plus 1 whole square minus 2 into theta plus 1 plus 4 into sin z. So e power z, so theta plus 1 the whole square is theta square plus 2 theta plus 1, here minus 2 theta minus 2 plus 4 into sin z. So 2 theta 2 minus 2 theta get cancelled, and 4 5 minus 2 is 3. So e power z by 1 by theta square minus 3, 4 plus 1 5 minus plus 3, sorry. So what do we get? Into sin z. So we have to replace theta square by minus 1. So e power z into 1 by minus 1 plus 3 into sin z. So e power z sin z by 2. So we have to replace z by log x. So e power log x into sin of log x by 2. So e power log x is x. So x into sin of log x by 2. So this is our Pi2. So final general solution is y is equal to Cf plus Pi1 plus Pi2. We have to add all those terms, then we will get the final solution, general solution. So to get the general solution, just you add, already we have Cf and Pi1 and Pi2, just you adding these 3 terms, we will get the general solution of y. So this is the final solution. Thank you.